Hello guys, my name is Adam,
And I'm Eric.
and we're here to demo our Python project for a class here at FSU. So this is our GitHub repo. You can find it at SpanishGum/Python web app with the usual prefix. And so what we are working on is displaying large data sets on a map inside a browser. For this project, we are attempting to support both Python 2 and 3. It currently works on both. That might change in the future. We have some of our requirements here: Flask, NumPy, SciPy, and Shapely. These are some common. This is a micro web framework. Some common scientific tools. Shapely is some GIS support. And so on here you'll find what you need to know in order to install the application, how to get it up and running. Eventually we'll have more information on our data sets and other tools that we use in this project, and you will find our to-do list to see exactly where we are in the project. We've made some headway on some of these. All of the blank check marks, don't be frightened by that. Anyways, so I'll go ahead and switch you guys over to PyCharm and let Eric take over.
Yeah, so if we come over here to PyCharm, like Adam said, we're using Flask as our server side for this project. And so when you come in, our Python project first starts in main.py. And you come in and you'll do a request to in the browser. And that will bring you up to this point of app.root. In app.root, basically it will get this index.html file and send back the correct HTML page to you. It does that by filling in the what HTML page you are requesting inside of our script here. And so after that, it can use some of our static pages that we have up here. Right now we don't have the pages for our actual overlays, but hopefully those will be coming soon.
Awesome. Okay, so that's essentially how Flask works, sending back and forth data between the client and the server. But some of the heavy legwork that we're actually working on is handling data processing. There is a large pipeline where we have start to the data from the data source all the way to the visualization in the map on the client side. There are several stages in this pipeline, and in our data module for this project we have begun writing a class that is going to handle this pipeline. It is not completely done. There are several stages that we still have to work on, but it is a starting point. So I'll go ahead and let Eric talk to you about the ordering of that pipeline.
Yeah, so first, the start of this pipeline is actually getting our data from our data sets, and we have 3 different data sets that we can pull from right now. Adam will bring up the Chrome browser here. Yeah, so over here, if you look, we have 3 different data sets. This first one is Samos, and basically in these data sets we have all these different variables in each document. And so the main one that we're interested in is point. That shows us the point on the map where for Samos it's ships, and we can take these points and then put them into our KD tree is what we'll be using for our data structure. And the other data sets that we have are iCodes up here and spurs. So once we pull this data from these giant data sets, we put them into our KD tree. And within that KD tree, we can then cluster. And by doing clustering, we can easily find nearest neighbor of n number of neighbors. And so we can pull the best ones out in order to show those on the map depending on what bounding box the user gives us. And then before sending those points to the client side, we will compress the data. By doing this, we greatly reduce the amount of data we have to transfer over to the client.
Mm-hmm.
And so I'll let Adam talk about the client side here.
Okay, so once these compressed data packets are sent to the client, it is the client's responsibility to decompress that data and extract out the different clusters so that they can be so that we can use those clusters to generate layers which are going to be placed onto the map. So since this is all happening in a browser on the client side, the functions that are going to perform these operations are written in JavaScript, and these JavaScript files are going to be sent to the user via our templates or our static files. This functionality hasn't been implemented yet. For now, we have an example that we found online that uses OpenStreetMaps as a backend. So we're still using OpenStreetMaps to give us a base map layer in our final application, but the actual source of data is going to be replaced from OpenStreetMaps with our own server-side data sets. And so hopefully this will allow us to explore different data sets that we can send to the user. And so yeah, I guess we'll go ahead and start the actual demo. I'll switch back over to PyCharm here so you can see exactly what I'm doing in the command line.
Yeah, so from the command line, we first have to set the environment variable for Flask. And you do this in Windows by using set Flask app and set it to main.py. And then after this, you need to start the server, and this is done by doing Flask run. And after you do this, the server will be up and running, and the actual web pages can then be queried.
Alright, so let's go ahead and move back over to Chrome now that our server is up and running. Whoops. Okay, so this is at localhost port 500. That is being relayed from the Flask microweb framework. So once again, this is the example data set that is pulled from OpenStreetMaps. But basically what this application is doing is it is capturing the state on the client side's browser where there is a bounding box, or in other words, a set of latitudes and longitudes that represent what the user can currently see. And those parameters are relayed back to the server, which gathers a data set, sends it back to the client in the form of several layers or clusters, and the client places these layers on top of the map. So depending on what level of zoom there is, will reflect a change in the data that you're actually seeing. So if we zoom in really close, you'll notice we have street names, different organizations, hospitals, national parks. Whereas if we zoom really far out, you have much lower resolution data such as states, countries, highways, major highways, border lines, coastlines. I think I've even seen air traffic routes, things like that. And yeah, so I guess we'll show you our fun little 404 page that we added, just in case somebody tries to go to a proxy that doesn't exist. And this is what you guys just saw a minute ago.
Yeah, so that's pretty much our whole project that we have for right now. Like we said, we have a lot of work to do still on it, and still need to do all of the overlaying. But once we have that done, hopefully it will be beautiful and functional.
All right, hope you guys enjoyed that. Thank you very much.